Hello friends, welcome to the NetMinion solution, and today I am here for providing you the information about the BGP protocol, and it is an introductory video only for the beginners. So if we talk about the dynamic routing protocols, there are two types of dynamic routing protocol. One is IGP, the second is EGP. IGP stands for Interior Gateway Routing Protocol, okay, and this can be either RIP, static, okay, or maybe static doesn't come under the dynamic routing protocol category, okay. So RIP, EIGRP, OSPF, ISIS, okay, so these kind of stuff come into the Interior Gateway Protocol, where it is coming under the same AS, under the same administrative party, okay. EGP is the Exterior Gateway Routing Protocol, the protocol for the internet choice, and we have BGP, which comes under this category, okay. So BGP is the protocol which is an EGP, okay, and it is an open standard protocol. So if we say BGP is a TCP reliable protocol, work on the protocol number 179, okay, and it is an application layer protocol. Now BGP can work between two AS, okay. If we talk about AS, what is AS? AS is autonomous system, and we can say in general terms that a single AS is managed by a single technical administrator, okay, like a company. Maybe we can say BT, maybe we can say Colt, Airtel, or any of ISP, maybe Orange, okay. So these kind of ISP have their own AS. This can be AS1 or more than one also, so that AS is under their administration only, okay. So if we talk about the AS more, AS is a 16-bit digit number, okay. It means its value will be from 1 to 65535, okay. This will be the range. So again, like IP addresses have private range and public range, likewise it has also a private range, and its private range start from 64512 to 65535, okay. Where we can use it? We can use it if we are running like BGP under an organization only, okay. We are not sending that information over the internet, or maybe for the MPLS, okay, where we are using the VPN connectivity. If you are not aware, maybe you have heard about this technology, okay. So if we talk about BGP, okay, so BGP is a path vector routing protocol. What does that mean? What does mean that it is a path vector routing protocol? It means that it will carry out AS information all together from end to end. If you see the diagram which is presenting over the desktop, okay, here we have 4 routers. Purposely I will prepare a lab also for you in the till the last, so be with me till the last here, okay. So the any of the information which is coming from the R4 to R3 to R2 to R1, this information will carry the AS information. Like if a route is coming from 400 AS, it will be like this, okay. What about this origin code? We will come later on this video, okay. So this is a routing path vector routing protocol. It means it will carry AS information, okay. So one thing that is important here, and that is, unlike the OSPF and EIGRP routing protocol, where we need to provide only neighbor command, only network command, okay, network command, and under the network command whatever network we were providing, this command like purpose, this command purpose is serving for 2 things, okay. First thing, it will start hello for that particular interface which are lying under this network. Secondly, it will start advertising that network, correct? And if hello is sending from one side and hello is sending from other side and all other conditions are also true, there is no multicast or something is blocked in between, then dynamically, automatically OSPF or EIGRP or RIP neighborship comes up. But this is not the case with BGP. Okay, BGP is a protocol where we need to, like any organization, if you want to run BGP, they need to provide purpose behind this. Okay, and ISP who are making the BGP with you, they will provide you a form with the proper kind of justification. Okay, you need to have an AS number also. So for BGP, the neighbors, whatever you need to define, it will not come up automatically. Okay, in this case the neighbors will need to define manually. Okay, and this is to ensure that your organization is capable enough to, you know, handle that BGP, and after that only, if that form is completed successfully, ISP will provide you the permission to make BGP session up with them. So need to define manually over here. Okay, so here is the one part. So second is, it comes like if you are making BGP, okay, if you are running BGP between the peer who have same AS, right, who have same AS, and BGP peer can be of the different AS as well. So who has the same AS as you have, then that is known as IBGP peer, interior. Okay, and exterior will be which have the external AS. Like in our diagram, R1 and R2 lies into the same AS number, that is AS 1200. Okay, and these will be IBGP peer. Okay, and unlike that, R2 and R3 lies into two different AS, and they will be EBGP peer. And likewise, R3 and R4 also into the two separate, they are having the two separate AS, and they will be EBGP peer only. Okay, so there are some properties for IBGP peers and EBGP peer. That is the reason why I am telling you. Okay, and when you configure the BGP, it will come automatically into the picture, like either you are using IBGP peer or EBGP peer. Now let us talk more about it, how to configure the BGP. Okay, let us start with that. Just allow me a minute. Okay, now whenever you configure BGP between two routers, okay, whenever you start configuring BGP, a TCP connection is established. As I told you earlier, it will be on port number 179. It is an application layer protocol, and the state between them should be established. If it is established, it means your neighborship is up. Okay, and over the BGP, single AS should be configured. It is not like the OSPF that, or EIGRP that if you are running OSPF 100 and by mistake you are putting router OSPF 1, that command will also taken in account. But here, if you are running with an AS like 1200 and you are putting some another AS like 1201, it will get rejected by the router, and it will say that I am already running AS 1200. For mitigating that, there are the VRF concept which come into the picture, but it is an later, like it will come in. We will check on that on the later videos, not on today's video. Okay, because it is an basic information about the BGP. So single ASN is allowed only, as I told you. Secondly, I told you that if it is IBGP peer, okay, and if it is EBGP peer, they will have some different properties. Okay, like AD value. AD value for IBGP is 200. For EBGP, it will be 20. okay, and EBGP, and it will for IPGP. Likewise, there are some other attributes which will have some different values. Okay, we will come on to that later on. First of all, let me tell you how to enable BGP routing protocol over two routers. Okay, so we will talk about this diagram only, and into the lab I will provide you the detail how to configure it. But first let me go through the commands. Okay, so first command would be, into the configuration mode you need to go over the router. Okay, BGP, then ASN number you need to provide. Like for R1 we will provide 1200. Okay, since neighbors need to be defined manually, we will put the keyword neighbor and then neighbor IP address. It can be okay, one point to be noted here, it can be your direct IP address, that is point to point, or it can be your another IP address also. Okay, for EBGP it is taken into the point, it is taken into the consideration that it should be one hop away only. Okay, howsoever it is for EBGP. Howsoever for IBGP there is no such rule. There can be like a number of hops. Okay, because if your organization has IBGP, okay, we like BGP used to think that you are running any kind of IGP protocol also, OSPF, static or something like that, so that if you wanted to make neighborship between the two routers which are not directly connected, like if you talk about this router and this router, if ping connectivity is okay and all the ports are opened correctly, TCP is getting supported, not blocked, then BGP will come up. Either these are directly connected or no, that doesn't matter. Okay, so for IBGP we need not to do anything, but for EBGP we need to provide some multi-hop command, but we will not discuss about the same into this lecture. We will come on that part also in our later videos. We will be publishing that soon. Okay, so let me clear it and let's come to the neighbor command again. Okay, how the neighbor command need to be put out. So for neighbor you need to define it manually, and here you need to write down like neighbor, then neighbor IP, because it is our first class, we will use a P2P IP, and here if you can see that I am using this kind of subnet. So first IP will be 1010, okay, because it is router 1 and router 2, so third subnet will be changed into 12. This IP will be 1, this IP router 2 for 2. Here for this link the first 2 octet will be 1010 only, because the router 2 and router 3 come into the picture. The third subnet I will change to the 23, and this IP will be 2 for router 2, and this IP will be router 3.3 for router 3. Here also the subnet information 1010 for first 2 octets, because here you are using router 3 and router 4, so third octet I am using router 34, so and it will be 3 for 3 router and 4 for 4 router. Okay, likewise, so point to point IP will be over the router 1 10.10.10.12.2. okay, after that we need to provide the remote AS. Like what is the remote AS router 2 is having? So router 2 also having remote AS 1200. It will be 1200 need to be put on there. Okay, after that if there are some networks you need to publish, then you need to publish some network. How to publish network, then network ID, then you need to put the keyword mask, and you need to provide subnet mask. Okay, here you need not to provide any kind of wildcard mask. Here the subnet mask is supported, so you need to provide subnet mask. Once you put this kind of configuration, your BGP will come up, and we will show you how to check further over here. Okay, so once your BGP will up, okay, you can see like three kind of table over here into the BGP. Okay, these three tables will be like BGP neighbor table, okay, and then BGP maintain its own routing table, that one. Okay, so we can say BGP neighbor table, then BGP routing table or BGP database table we can say, okay, and the global routing table. Okay, regardless, with any routing protocol, the global routing protocol will be checked by show IP route command. Okay, BGP, if you need to check, it need to be shown by show IP BGP. Okay, neighbor table can be show IP BGP summary first, then show IP BGP neighbor, and this command will tell you either the state is connected or not. Okay, there will be a lot of more information in these commands which I will tell you, keep on telling once I will configure the lab. Okay, and you will see and you will understand exactly what is happening and how the information will be sent. Okay, so once the BGP comes up, it will send its whole routing table to each other. After that, it will be get incremented, and it maintains some kind of BGP table which keep on updating once any kind of update or some routing information get changed. Okay, this kind of table should be same for your neighbors. Okay, and afterwards keep alive packets of course needs to be sent to check the mechanism, either your peer is down or up. Okay, so this kind of stuff will be taken care. Now we will talk about some kind of BGP status code and origin which I was telling you. Okay, so let me come to that, just allow me a minute. So there are some origin codes for BGP. Okay, as I told you, BGP networks should be published by the network command under the BGP, and one thing more, the network will be get published only and only if that network exists over the router. What does that mean? So R1, we will publish two loopbacks over here. Okay, that will be 10.10. The third octet will be changed only to the 1 for router 1. For router 2, the third octet will be changed to the 2, and for router 3 it will be changed to the 3, and for router 4 it will be changed 4. Then it will be, this value will get increased as per the loopback. Like loopback 1, this value will be 1. For loopback 2, this value will get changed to 2. Likewise. Okay. So I was telling you something that in network statement will advertise only those routes which exist into your routing table. So R1, over the R1, if under the BGP I publish some networks like network 10.10.1.1 with mask 255, 255, 255, 255, all 255, it will not get published until or unless I will make the loopback up. Okay, so I will create a loopback 1, and I will give the same IP address here with same mask. Then BGP will start advertising it to its peers. Okay, otherwise BGP will not advertise to its peer until or unless these kind of routes which you are advertising by the network statements exist into your routing table. So these can be come through the static, through connected, through maybe another protocol like OSPF, EIGRP, any protocol. So it doesn't matter from where you are learning it, but it should be present under your routing table. So I was telling you about some status code. Okay, so status codes is like that. When you run the command show IP BGP, okay, show IP BGP, you will check some status code. Okay, so before status code, let us talk about origin code. So origin code, if we talk about, there can be I are those network which are getting published by BGP under the network statement, first of all. Okay, secondly, it can be question mark. Question mark are those networks which are redistributed by any of the another protocol onto the BGP. Third, it can be E is for the EBGP. E is for the EGP, exterior gateway protocol, which doesn't exist now because it was a legacy protocol, and now BGP has taken care about the EGP protocol. Okay, there is no such protocol exist. Howsoever, into the route map we can literally make any route with the tag EGP, but ideally it is not happened. Okay, we do have lot of attributes over which we can play. It can be done, but normally it doesn't come into the picture or into the real world scenarios. You will not see it. Okay, so we were talking about the origin code. I have provided you the information that origin code can be I, can be question mark. Okay, and in our scenario, what we gonna do is we will redistribute some routes over the R4, maybe 44, some route, okay, into the R4, and over R2 and R1 we gonna check it should become with question mark. Then we gonna advertise some kind of loopbacks, and again loopbacks range. I told you that the third subnet would be 4, and it could be 1.2 into the R4, and this should become with I over here. Okay, the origin code should be I. Likewise, you can publish 2 loopbacks here also, 1 loopback here also, 1 loopback here also. Okay, so we will check it over the routers also, and we will provide you all the information. But before that, I am making some kind of background so that when I would about to tell you regarding the same, you should have proper understanding about that. Okay, so this is the basic information about the origin code. Now let me come to the status code. Okay, what are the status code and how you will see that. Okay, so there are 2 status code. One you will see like that, okay, and one would be see like that. So one would be the star, which means the route is valid. One would be the greater than side, so okay, greater than symbol. So this will tell you about that the route is best. So once any of your route under the show IP BGP command show like that, it means this is the route which will be advertised to another peer by your router. Also it will be get installed into your routing table also. Okay, until unless your routes are not coming, not having the valid and the best symbols, it doesn't gonna install in your routing table. So I am making such kind of scenario that you will see the same problem over here. Okay, and I will let you know why that problem exists and how to mitigate that problem. So be with me. Let us start with lab now without any delay, and let us check how to configure BGP over R1 and over R2 and over R3, R4, and we will check all of these informations in couple of some time. So before that, let me talk about next hop also. So next hop is the value which will be shown into the show IP BGP command, which shows you what is the next hop, like how to reach that route. What is my next hop to reach? Like for R1 it should be R2 if R2 is publishing any routes. If R3 is publishing any route for R2, R3 will be next hop. But here is the catch, because it is IBGP doesn't change next hop value. When this route will be sent to the R1, and over R1 you will see next hop value of R3 only. Okay, but for eBGP next hop always change. So this question is too much important also, and I have provided you some kind of hint also. So for mitigating that, we have next hop self and other commands, but we will play with static, or we can play with any kind of IGP also. Okay, we can run any kind of protocol which can mitigate such kind of issues. So if your next hop is showing 0.0.0.0, it means it is coming or it is generating by your router only. Okay, one thing more, under the iBGP the AS path value will not come by any mean, because it is under your AS only. But if any eBGP peer is coming in between, then your AS value will change. Like for router 3 routes, you will see 300 or the origin code, whatever it is, and for 4 route it will be 400, then 300, likewise, and whatever the origin code it can be. Okay, so we are gonna check that without any delay now, because this is a very short class, we cannot extend the video up much. So let us start. Okay, we are going over the router 1 and making the BGP configuration from the starting. Now here is the router 1. As per the diagram, I am going into the config T. As I told you, I need to go into the BGP, and if I put question mark, it will ask for the AS system, and I have provided 1200 as per the diagram. Okay, now here do show IP interface brief. If I show you, I used the third subnet 12 as I told you in between router 1 and router 2, and over the router 1 I have made 2 loopbacks, so that in routing table these kind of stuff can become as a connected. Okay, you can see it by the command show IP route connected routes. So connected routes, there would be 3, 1/24, which is coming between R1 and R2, and these 2 loopbacks, loopback 1 and loopback 2. Okay, now over this BGP table, what I need to do, I need to make this BGP up from R1 to R2. Okay, and I need to put neighbor manually, so I will put command neighbor, then question mark. If you will put, it will ask for the IP will be, IP will be 12.122. then you need to provide remote AS, and the remote AS will be same, that is 1200 only. Then you need to make your network up, so network would be 10.10.1.1, and mask is 255, 255, 255 and 255. Likewise, you have the second loopback, that is with IP2, and your link in between the router 1 and router 2, you should publish that also. So here you go, you have published all of the things. If I go to the router 2 and check my diagram again, here there are 2 kind of neighborship. Okay, one neighborship is between R1, okay, and one neighborship is between R3. So I am gonna make this neighborship up first, then we will configure for R3. Okay, so let me do that. Conti router BGP 1200. Okay, the neighbor 10.10.12.1 remote AS, again it's for 1200 only. Network, if you check here, do show IP interface brief, we have again 3 networks here, 12.2 between 1 or 2, 23 between 2 and 3, and one of its a loopback. So I have made the neighborship app, and it is a something slow protocol. It will be up in a couple of in 1 minute. Okay, and it is up now. Let me publish the network also, 10.10.2.1. Okay, now let's go to the router 1 and check show IP BGP neighbor command, where I was telling you that it is flooded with multiple of the information over here, and we can check couple of the information. Okay, not complete information, but couple of information we can check, of course, here. And let me tell you about the state, which I was telling you that it is maintaining some kind of state. Okay, so So if you check, it is providing the neighbor IP, okay, and again what is the neighbor remote AS, okay, and it is an internal link. It has already described. What is the router ID? So router ID concept, again either it is BGP, OSPF, any. So it is the name of that router. BGP version is standard 4, state is established, it is up for how much time, okay, last read and couple of those stuffs, then notification and these kind of the packets, okay, send or not, whatever the information you can see here. Now hold time and the hello time, you can see here that it is 180 and 60 by default, and that is all right for you, okay, till now. Now let us check about the another command, that is show IP BGP summary, okay. Here if you see that BGP is maintaining couple of things over here also. If you check quickly, okay, so BGP router identifier, it is showing about its own read, okay, because the third subnet you can see is 1 and 2 is the bigger, like the highest IP you can say, or loopback IP, so that is taken care. Local AS, it is telling about that my local AS is 1200. This is the table version which I was talking about, that this version will keep on updating once the routing change happened, okay. How much memory, what kind of stuff is taken care, that is already provided. Here you can see the information about neighbor. Here you can see about the version of the BGP, that is 400. AS you can see message, how many messages received or sent, okay. In queue or out queue it should be 0, okay. What is the uptime, it should be seen here. Now here it is showing that prefixes are 0, which will keep on increasing once you will advertise the network, okay. And this should not be active means it is actively looking for the neighbor, so that is not good. It should not be active over here, okay. It should not be idle over here, it should not be admin shut over here. So that state means the membership is not up. So if there are something like this kind of output, it means it is good, it is up, and the prefixes can be n number of prefixes as per your scenarios. It can be 1000, it can be lakh, it can be 7,50,000 if you are importing the internet table, okay. So that depends upon your scenario, how bigger your environment is, okay. So this is again the second command. Now if you check show IP BGP, here you go. What I was talking you about, the status code and the origin code is here, okay. So if you see, all of the origin code is I, because all of the routes you are advertising into the BGP only, and you can see all the next hop is 0000 because all the routes are provided by the router 1 only. You can see here from here, okay. From the third octet you are able to recognize either it is provided by some another router or from the router 1, okay. So there will be no path information also, but if any route will be come from 4, it should be like 400, 300, and your means like if there are a number of AS in between, it will show like that, okay. So this is the whole information till yet. And if you check about this status code, all of the routes are best and valid, okay. All of the routes are best and valid and best, okay. So you can see this status code information over here, that star is valid, the greater than symbol is the best, then I is for IGP, IGP, and E for EGP, and question mark is for incomplete or the redistribute, which I was talking you about, okay. So now let us make the BGP up for all of the routers so that we can have some more doubts and some more networks would be available. So here I put only network command with 2.1, that should not be the case. Otherwise it will take by default IP address, and by default subnet mask is class A, which should not be the case. So I need to provide properly mask. It should be 255.255. okay. Likewise I will provide the network 10.10.23.0 mask 255.255.255.0, and one we have 12. Need to make neighborship up with 10.10.23.3, which has the remote AS300, and we will save this configuration. Here also, if you check, we need to save this configuration. Let's come to the router 3 quickly and make it configure for router 3. Router BGP 300, we need to create two neighbors. One is neighbor 2, that is 10.10.23.2, whose remote AS was 1200. One is for neighbor 4, that is 10.10.34.4, remote AS will be 400. Then I need to publish network will be 10.10.23.0, and you can see that neighborship with 2 is up already. okay, mask 255.255.255.0, and likewise I have 34 subnet here, and I am publishing its own loopback, which will be in the third octet. It is router 3, so it should be .3.1 and WR. Over the router 4, if you see conti router BGP 400, I am configuring a neighbor point-to-point with router 3, so it should be 34.3. remote AS 300. Then network, it has two networks here, 10.10 4.1, mask 255 255 255 255. Again it should be the 2, and the last one is 0, and it should be 34 subnet. okay, you can see that neighborship is up end to end. okay, now let us come to R2. Why I'm not coming to R1, I will let you know in some time. okay, if we check on the R2 show IP BGP summary, you can see some kind of stuff here. okay, so let me explain about that, what this all information is telling about. So first of all, you can see that BGP version is increasing now. okay, now if you talk about this AS information, you can see that 12.1 is having AS number 1200 and 12.3 is having AS number 300. okay, then from when these two neighbors are up, you can see what kind of memory, of course you can see that. okay, now state or prefixes, like how many prefixes you are receiving. So your topology was like R1, R2, these are into the same AS, then there is R3 and there is R4. There is a very simple topology which I am using. okay, there are two routes which I am publishing here, there is one route which I am publishing here, and these all routes are coming here. okay, and meanwhile it will be keep on increasing because this route should also come, and we will check why it is not coming yet. It will become soon. okay, and over R2 there are two neighborship which should be seen. okay, this color is little bit okay, so there should be two neighborship over R2, this and this, R3 and R1. okay, over the R2. Likewise for R3 it should be R2 and R4. okay, over R4 it will be only one neighborship, over R4 sorry, and over R1 also there should be one neighborship. So till so far you should not have any kind of doubt. okay, if you have any doubt you can put it under the description or under the comment. I will take care about that. Show IP BGP summary I have provided, and as I was telling you that prefix will keep on increasing, and it is increasing. okay, now let us come to the another command, show IP BGP. and talk about this command. Okay, over here, so show IP BGP. If you check now, whatever I was telling you earlier, that you will have the status code, some kind of thing stuff. So status code, because all of the routes are currently putting by the neighbor command only, so this status origin code, it is I only. Okay, now here I means that it is coming through IBGP. Okay, IBGP will show I over here, and this I means the origin. Okay, these two stuffs I hope should be clear to you. Now if you see, these all routes are valid and best. Okay, you can see, except this one. Okay, why it is not, we will check about that. Okay, so let me clear the screen again and let me run this output once again so that we can have proper update. So let me bring this. Okay, so now talk about this route 10, 10, 12. If you check, this route comes between R1 and R2. Okay, this is R2, this is R1, and we are talking about this route. So this route is getting published by yourself only, that is next hop 000, and it is coming from 10, 10, 12, 1, that is R1 also. So it is rejecting R1 route as it is accepting its connected route. Maybe you can come later on, we will come later on over the weight and other attributes, but if you come to the AD part also, that also the connected will win as compared to eBGP or IBGP. Okay, and likewise 10.10.23 part is also coming by 10.10.23.3 and by itself, and it is preferring itself route rather than it is not accepting that is one which is coming through the R3. So this is the common route which is coming from the R3 also, and it is generating by itself. So it is accepting the route which is generating by itself. Sorry. So this is the case. Okay, so now let's come to the R1 and let us check the same information. Here we need to show you the next hop command, and I will show you that the link which are coming through the R3 or R4, that will not be getting accepted, okay, until unless we have some protocol. Okay, I hope I have running show IP route, the static here, show run section IP route. There is no show IP route. Great. Show IP BGP. Just allow me a minute. It is misbehaving or what, that I need to check. Show IP route. Okay, because we are advertising that link through R2, so it is sending that information to R2. Okay, maybe for your information, what we can do for conti router BGP 1200 and no network 10.10. It is 23.0 mask 255.255.255.0, because we are providing all of this stuff. So whenever you need to do any change, you need to do clear IP BGP star. It should be soft so that none of the BGP neighborships should reset. Now this route is not under this table, and if you check the show IP BGP command again, you can find out the thing which I was about to tell you. okay. And here if you see what I was telling you, that if any route like R1, it is R2, it is R3, it is R4, and these are EBGP, these are EBGP, and this is IBGP. So IBGP will not change the next hop, and it will be R3 IP address. Okay, if you see here, it is R3 IP address all over the route for router 3 and for router 4 routes. And either it is coming to R1, okay, but it will not be the best route. It is the valid route, although it is not the best route because it doesn't have the information how to reach the R3. So for that, either you need to advertise over here, or advertise through the IGP, okay, or because it is a small network, IGP is not required over here, but either you need to run IGP, or you need to put next hop self command over here, or like any kind of these kind of methods can taken care to put this route under the routing table. So we gonna do again, and we will put again this route under the network table of 2. So conti, and under the BGP routing table we will publish this route again, and over the router 4 I am now redistributing some kind of stuff. Show IP route, if we check, there is a static route already. So I am going into the config mode, into the BGP, and I'm redistributing the static protocol here. By redistributing static, the static route should appear here, the 44 route. Okay, show IP BGP. If I check now, the status code or the origin code, if you check, you will come to know how it is behaving, because origin code is question mark because we are redistributing static. The AS path is showing that it is redistributed at where? At AS 400. The status code is still showing that it is receiving by IBGP. So R1 is peer of R2, which is IBGP peer. Hence all of the routes which is coming to the R1 will be shown by the IBGP peer. Okay, however this information over the R2 will not be the same. Okay, let me show you. Over the R2 only R1 routes will be shown as IBGP routes, otherwise all other routes will be EBGP routes. So show IP IBGP. If you see and if you compare R1 and R2 information, you will come to know, like here only R1 routes, the routes which is provided by R1 are showing like I. Okay, none of other routes are showing here. However, for the origin code, it will be appeared same on all of the routes. So this is a brief description about the BGP, and I hope you like it, and I hope I tell you about something over here, and I will request you to like my video and to comment over here, and how I can make more videos on which topic and how should I